the return. That sounds great. For what we're using it for. But from a server-side point of view, you've got thousands of connections. Now, if each one of those connections has a thread associated with it, then certainly in .NET, where each thread has a default stack size of 1 meg, you're looking into trouble. 1,000 connections, possibly okay. 10,000, okay, because you can see. But wouldn't it be nicer if those threads weren't really threads, if we just had requests, and when something happened, we could just leap back in and say, hey, everyone who was interested in that, you now get a chance to return. Great stuff. So it really depends on where you are, and the magic isn't going to stop a user from interacting. And if they set some value on a text box, then when you get to the next bit of code, if you ask the text box for its value, you'll see that new information. Sometimes that's exactly what you want. Other times it won't. In particular, suppose you want your user to be able to cancel this long-running task. If they hit cancel in here, then possibly this operation supports cancellation, and you can cancel that, it won't take any resources. But either way, you can notice as soon as you do get back in and say, I'll stop doing this operation because I don't need to do it. So sometimes it can be a blessing, sometimes it can be a blessing.
So it's something really
defining long run. It's entirely up to the user, the developer rather. For Windows 8, long running is defined as 50 milliseconds. In that, if you're going to do anything that might take more than 15 seconds, you're strongly encouraged to make it asynchronous. 50 milliseconds isn't very long. So you really do need to be thinking of doing very little in the yes, in each little segment. The whole thing, well, the whole thing can take a very long time. And I'll show an example where it takes maybe 5 or 10 seconds. Obviously, it could take a lot longer. Yes. I would argue that if you're doing anything that's going to take 2 weeks, you will be regularly checkpointing, etc., so you can recover, and things become a bit trickier. But in particular, if you're checkpointing and trying to recover from where you were, you'll be doing some of the work that I'll show you later on what some sharp compilers doing. Anyway, but if it's a reasonably simple, I'm taking this chunk of work and processing each item, and here's the output, then that would be fairly straightforward. But yeah, your overall long-running operation can take as long as you like, but you don't want to be blocking the wireframe in a way that the user might notice. Okay, very brief introduction to task of T. For those of you with more of a computer science background, you can think of task as a future. I only mention this because it's part of the language specification now, effectively. So this is the promise of a result. If you want to see sharp further, these angle brackets are generics, like in Java. So a task of T is a promise to return a value of type T later on. So as an example, the web client type has a new download string task async, which is a bit of a mouthful, but that returns a task of string. So you give it a URL, it gives you the promise of when it's finished fetching stuff, it will give you the text of web page. That's a VH string. Okay? You can ask the task of T to log until you get the result, the result property. You can ask it to have a continuation, so you can say, continue with this block of code when I've finished, or when you finish rather. You can check for its status, etc. And also, it supports the awaitable pattern that I'll explain. I'm not going to do too much trying to describe the feature without showing it to you, because describing code just doesn't work compared with seeing it. But I will refer to this diagram a few times. So, I don't know whether the webcam's going to pick any of this up. Think of, if I'm over here, I'll probably be talking about the caller of an asynchronous method. Then there's the asynchronous method itself, which will be decorated with the async modifier. Then there's the async operation, which can be fetching something from a web service, loading something from a disk, loading something from a database, doing something locally in a different thread, any number of things. The boundaries between those three blocks, so effectively what makes either the return value or makes the return value work, between the caller and the asynchronous method, you either have void, which basically means when you call me, I will start doing something and you won't have the faintest idea when I'm finished. It's really only there to help with event patterns. Or there's task, which you can think of as task of void, which is I don't have an actual result as such, other than whether I completed and whether there was an exception. So the synchronous equivalent of task would be to return void. Or there's task of t, either generic or some kind of t. So an async method can declare that it returns a task of t. And within the async method, when you're going to do something asynchronous, the way that the compiler works out that you've got something asynchronous that you can await asynchronously is that it implements the awaitable pattern, and I'll definitely show you that in code. Right, demo code time. Forgive me for this one. Now I have lots of code here, and it's 1:06 already. I know that really you won't get to talk to the AGM, so I will try to be rude. But I will basically ask you what you want to see at any one point. We'll start with a simple application. I'll show you the app running, and then I'll explain what to do. So it's fairly small, but I've got a username and password. If I put in the wrong password and hit check stocks, it will fairly quickly come back to me and say that's wrong. If I put in the right password, it's currently authenticating, and we can see what it's doing with the debug bit. It's authenticating, it's fetching my stock holdings, all of this is completely mythical, of course. Then for each of these stock holdings, where our holding is stock ticker and quantity, it's then fetching the price of each stock ticker, doing a bit of multiplication, or not when it can't find the price of a particular stock ticker, adding it to the portfolio, and giving me a total again. It's reasonably simple, but aside from anything else, we've got three different services: authentication, holdings, and prices. And if we want to think not only in terms of asynchrony, but parallelism, we can't parallelize anything else with the authentication, because until we're authenticated, we don't even know what user ID we'll use for finding out holdings. We can't fetch the prices before we fetch the holdings, because we don't know which prices to fetch, but we could parallelize fetching each of the prices. Currently we're not, and you can see this is very small, but I've got timestamps with each price fetch, and I've made it pause between 1 and 2 seconds for each of these prices. Just to demonstrate, while it's doing stuff, the user interface is still responsive. Oh, I forgot that so yeah, it's all responsive while we're working. Very simple. Let's look at code. So if you've done any C# before, I'd like you to imagine what this code would look like if you were writing it in normal Windows forms. There are two fairly obvious approaches that you could do. One would be to do it using asynchrony and add all continuations everywhere, and that would be tricky. The simpler way would be to use a background thread to do all the actual business logic, as it were, and then whenever you wanted to update the UI, you would have to go back into the UI thread, update the user interface, and you could do that itself asynchronously, but you'd have to remember to do that. Let's have a look at what we actually do. So I'm not going to pretend this is all lovely code, but at least I have got some sort of separation of concern. So I've got interfaces for the different services involved. nothing interesting in the constructor. When you click the button, it calls into this fetch stocks method, which is itself decorated with async, but really is just does a little bit of preparation. So it clears out the stacks, calls into this fetch stocks async, and then lots of all the interesting stuff is in here. So I'll concentrate on this. So, two things to note from just the declaration. This method is decorated with the async modifier. This isn't really needed. You got to put it in, but the C# team didn't have to put this into the language at all. They could have said, like they did for iterator blocks, which is sort of the generator pattern, if you've got any await expressions within the method, then I'll assume it's meant to be async. However, that has odd effects in that if you commented out the last await, then the execution flow would completely change, which isn't nice. And also, it kind of tells the reader, you should expect that this is going to be asynchronous. It returns a task, as in, we haven't got anything useful that we want to return from this method. It does everything that it's meant to do without producing an overall result. But someone might want to see when it's finished, and might want to see it as it is. Okay. So, I'm not going to explain to start with what the await keyword does, but just follow the code without thinking too strong about it. So we start off with a try block, and unfortunately the finally block is all the way down here. So all we're doing in this try finally is saying we're going to initially stop the user from fetching again while we're still working. So we can see that working. If I hit fetch stocks, it's grayed out button. And however we complete, even if I get the wrong password, so when that has completed, I didn't have cancellation for this example. Even if we get a failure, when we clear the message box, the button pops on again. So this is try finally working as we'd expect. However we leave the method, it's going to enable the button. The actual code, log is just a utility method. It's nothing very tricky. All it does is directly pull append text from text box. So we better be in the UI thread if we're going to do this, otherwise we'll get an exception for cross-thread declaration. So you can see log peppered around the place, which means we're definitely always in the UI thread whenever we're executing any of this code. So we do a log, we call it into our authentication service, and that returns a task of nullable query. So the idea is, if we manage to authenticate, it will return the user ID. If authentication fails, it will return that. It's not the only way that we represent the failure, but let's go with it for a moment. So we fetch the user ID, check whether or not it's null. If it is, all we need to do is show the message box and then return. Note that we're just doing return, even though the method itself returns task, we're just returning as if we were returning from a void method. We then fetch the stock holdings. So again, we call into our dependency, our portfolio service, and we call get portfolio async, passing in the user ID. This time I haven't bothered showing it, but that returns a task of list of stock holdings. So it says, you will call me this method, and I promise that at some point I'll give you all the different stock holdings for the particular user. And again, I'll use it. Finally, we're going to actually call into another async method. One of the nice things about asynchrony is its composability. And this time we've actually got something that returns the task of decimal. It's going to return the total. So given all the holdings, fetch prices, which our initial stab at this is just going to be synchronous, or sorry, it's not going to be parallel, it's asynchronous, it's an async method. We're just going to loop over each holding, look it up, add a portfolio entry to the grid view thing. If we've actually got a price for it, then we'll add it to our total worth. And then at the end, we'll return total worth. Now again, note that the type of total worth is decimal. If you're a Java programmer, think big decimal, not quite the same, but similar. And we're just returning that. And again, the fact that the method itself returns Pascal decimal is all just wrapping. So we've already seen that when we return, the compiler is going to wrap our result in a task of T. And the other side of this is the await keyword that I asked you to forget about for a moment. So before I explain what it's doing, would you all agree that that looks pretty much like you would write the synchronous code if you didn't care about blocking the UI code? Yeah? You can follow this code. It's not spaghetti code. And believe me, it would look a lot simpler if it went to the 19 font that takes up the whole screen. This looks like two fairly small numbers. So what does await do? Well, it takes, in these particular cases, a task of T, waits for the task to complete, and then unlocks it. And that's all. The only thing is that while it's waiting, it isn't blocking. So effectively, from the caller's point of view, the original caller, this block on the left, when it hits an await expression, the method might return. It might not, because the task may have already completed. If we were hitting the cache of something, there's no point in doing context switching and attaching a continuation, all kinds of cunning stuff, if we're immediately going to get pulled back into the continuation and keep going. So it's not like await always shoves everything off to continuations. But it often does, and in this case, I can pretty much guarantee that it does because I explicitly put delays in it. So when we hit this await, the method will return, and you might think, well, how can it return? I suppose with the task it's not so bad, but with the task in decimal, how can it return when it hasn't got the result? Well, it doesn't need to have the result, it just has to have the promise of a result later on. So, we're at the situation where we called into our asynchronous operation, and that has quickly returned us the promise of our user ID or our holdings or a simple price. The asynchronous method is saying, okay, I can't do anything else until I've got the value out of that task. So it says to the asynchronous operation, please call me back when you finish. And then says to the caller, okay, I'm done now. Here's a promise of, here's something you can watch to see when I finish. And it's out of there. All stack collapses to whatever it needs to. Then, later on, this asynchronous operation finishes. And it says, hang on, I've been told when I've finished, I've got to call this chap over here. So we call back into our asynchronous method. The cunning bit, the bit that the compiler spends quite a lot of effort doing, is making sure that if we get to, for example, this await here, the continuation points to the end of that expression. So it immediately keeps going, and we're in the middle of a loop here. Well, it just keeps going in the middle of a loop. And likewise, earlier on, even though we were awaiting the authentication task, you might think, hang on, but we're in a try finally box, so when we return, it's going to re-enable the button early. Well, no, because the compiler realizes that you haven't really returned from the method. You're just kind of pausing it. So it doesn't run finally blocks on its way out at that time. It will only do so when you logically have reached the finally block. And it also makes sure that when you do an await, when the asynchronous method awaits an asynchronous operation, it captures the context in which it's already running. In this case, the UI thread, but it could be other things. For example, if you're on a thread thread, you probably don't care which thread thread you come back and execute the rest of your code on. But you could do whatever you want. You might have multiple thread pools and make sure that you come back to the same thread pool. Maybe you've got a high priority thread pool, and the low priority code. Some operations you want to be really high priority, others you don't care when they run. So it will come back to the context that you call this on, and make sure, in our case, that all of our async method code runs on the UI code. Doesn't matter if this guy over here might have used other threads, or it might not. It's just an asynchronous operation. One way of getting a task is to say task.run some method or some block, and that runs in a different thread. And you can await the result of that without blocking the UI thread. This just goes off in the background, and then the continuation gets posted, and the way it happens to get posted, you get to run all of your code in the UI thread in one synchronous looking bit of code. For a Windows form app is the same as if we called control document. Yes?
Should I think of execution rules?
Yes, absolutely. This is like a pause button.
And then on only code
well, we've said that we haven't got anything more that we want to do on this thread until that's finished. So something else can use this thread and the user can move Java around. So it's paused, not in terms of the thread, but in terms of the method. And that's the tricky bit to get your head around. Speaking of tricky bits to get your head around, what would we like to see next? Okay, the choices are, I can show you how this works under the covers. I should probably actually next describe the awaitable pattern, but just to tempt your taste buds, we also have how on earth would you unit test things like this. A bit of an example of composition. I can make this go in parallel. I think those are the simplest examples. The idea of composition, I can show you a magic trick, which just I love. I will definitely get that in. It's just the most fabulous thing. Yes.
Maybe I'm not understanding. Can you see the bit the next one where you go find all the prices?
Yeah.
There's an await somewhere.
There's an await here. So
yeah,
we're going to look up the price and await the result.
If you're waiting there, then how do you carry on going around the loop to get the next price, and how do you therefore do them all in parallel?
So this isn't in parallel.
Ah, okay.
This time isn't in parallel, but it is asynchronous. So we're not going to be blocking anything, but it's done. So it's really important to understand that asynchrony and parallelism aren't the same thing.
So you're not blocking any other threads, you're just blocking this thread.
No, we're not blocking this thread.
You're holding this.
No, we're not blocking this thread. We're pausing this logical operation. Yeah.
But you can't you're not executing any more of this thread, are you? Till you await this, till you await.
Yes, absolutely. We're releasing this thread. And so the confusing bit is we tend to associate a stack with a logical operation, and this separates them. Right. So the first time, if we get to let's think about the very first await expression. Okay. When we await this, we will actually have a stack trace. If we throw an exception here, we will have a stack trace that shows fetch stock setting, and that being called by fetch stocks, and that being called by a button click handler. Okay. If we then looked at the stack immediately after the await, we wouldn't have that stack trace anymore. We would just have the message loop that said call into the continuation. Okay.
Isn't it that particular stack frame wrapped up in the how you in the continuation?
This is why it's difficult to do by hand. So the compiler is making it look as if all this, we're used to thinking of, hey, this is on the stack, right? Well, not so much really. Okay, so it's doing the magic to make it look like a familiar execution environment, whilst separating out the idea of a stack from the logical flow of method.
Is it really difficult to use it from code routines or not?
I have implemented code routines in this, and it's fun. I've implemented come from, in this, which is foul abuse of it. It requires doing something that the language specification explicitly says you should not do, which is executing the same continuation twice and poking it. So like I mentioned the secret earlier, this is all built in state machine. And if you hash around nastily enough, you can say, hey, state machine, I want you to be in state 2 now. Going back to an earlier continuation. Don't do that. But yeah, it's doing all of that stuff for you so that you don't have to, because it's really error-prone. Yeah.
So just to confirm, so when the await happens, the stack gets unwound, and it goes back to what was invoked this whole thing, which was a button handler, and that button handler goes obviously inside with API.
Yeah.
And then that thread gets at that point, and then obviously probably goes through the WinProc and Skeet's other handlers.
So
including possibly more of this stuff.
The button handler calls out top level thing, and that calls down into this async method. And then as soon as that says, whoa, I can't do anything for a while, I don't want to block the thread, everything unwinds as far as it needs to. If the button handler needs to do, maybe we've got the second handler, that starts executing, and it goes back to the message loop. The message loop goes idle, or maybe you wiggle mouse around or whatever. Then when the continuation is called, it's called directly by the message loop. So we don't have, it doesn't rebuild all of the stack for you. It just makes sure that your context in this method, all the local variables that you've got, the fact that you're in a loop, etc., it propagates all of that context.
I just thought there's some people have trouble understanding, as you say, when you hit await, that the thread is released. What's the thread doing? If the thread has gone back to the WinProc and the prop has gone forward, that's where the thread is.
Exactly. So the thread is being the normal idle UI thread, or in the case of the thread pool, it's sitting in the thread pool, or in the case of coroutines, it can be executing the next bit of coroutine. It doesn't have to be idle. Why don't I show you what the await does now? The awaiting pattern.
You can't step through the code.
You can. So let's do that. I should be able to. I just install it. Right, I'm not much of a debugger fan, so there are all kinds of tricks that I don't know anything about, I'm sure. So one thing we can see, this is probably too small to see, but we've got the top stack frame is fetch.async, called by fetch docs, called by control.confet, called by button. And I will now step over step, and we haven't awaited anything yet, so we're still just executing synchronously, but we've got a task. And ironically, if I just sit here and talk for long enough, that task may now have completed, because all it's doing is authenticating. In fact, I don't know whether it will, because this is just using task.delay, which is a sort of asynchronous version of thread.sleep. If we have a look at fourth task, and it's still it's waiting for activation, so I think it's still going to wait. So watch the stack frames. Yep, here we go. We're in a move next runner, so actually we've got a huge amount of stack that's dedicated to the machinery of async, which you can mostly just ignore. But importantly, when we get right down here, we don't have anything that's doing our own code. We've certainly exited all of that. And we can just keep going. So you can absolutely debug, and any exceptions thrown, there's stuff in .NET 4.5 to manage to give you something looking like a normal tag trace, even if it's been thrown by a thread. There's extra help for marshalling that kind of thing. Any more questions before I show you what the pattern required for a way to do this? Yeah.
So, what if this statement variable total was equal to await?
Sorry, which one? The
simple, the first statement where await was.
Yeah, the finding the user ID.
Yeah. If you copy it and paste it again in the next line.
Yeah. so awaiting the same task, yeah. Then, because this has finished already, the second time, the await expression will say, have you already finished? Oh, you have. Okay, just give me the result, please.
No, if the same user ID can do it.
I'm not sure I follow.
Yeah.
So you can
Exactly
certainly
same
do, right?
statement.
Well, it would have to not include the declaration because you can kind of the same
Okay.
place. But
Now what happens?
basically, this would assign the same value to the variable again, and because once a task is completed, it doesn't uncomplete. I like to think of a task as being like a cardboard box that says, I'm going to have a cat in at some time in the future, and I'll tell you when. Well, when we've already opened that box to have a look at the cat, if someone else says, could I have a look at the cat? It's not like you close up the box again and say, right, you've got to wait a while. No, you can already see the cat. So it doesn't need to do anything at that point. It can just say, yeah, sure, here's the result. Indeed.
Yeah, but if you wrote instead of the second order task the whole authentication service up there, then it would wait again, wouldn't it?
Absolutely, yes. Yes, there is no magical caching going on. It's just that the task itself knows it through the
And what is the purpose of is the garbage collector actually here?
The garbage collector, there's some interesting stuff about the garbage collector here, in that until you hit the first await, all these variables, all the local variables, genuinely are on the stack, because the state machine that's generated is a struct. Apologies for those who don't know C#, this is going into C# and .NET specific stuff. So the state machine sort of wants to be a class on the heap because we're going to be calling into it for different things. And in particular because if your stack disappears from under you and you want to still have these values around, it's got to go on. The way it works is it's a struct, it's on the stack until it needs to be, until you need to release, at which point it gets boxed onto the heap. Cunning stuff happens to make sure that it's got a reference to itself so that there's only ever one box value on the heap that's got all these local variables in it. And that can only be garbage collected when the whole async method has completed. It makes sure that none of this is garbage collected before it should be certain. Okay, let me show you the awaitable method. So this is an example. No, not a solution. This is not what things actually look like, because a lot of this is pattern-based. But you can sort of think of it as if task of T implemented IOwaitable of T. So if you're familiar with IEnumerable or Java iterable, where you say, get me the cursor to iterate over this thing, we've got something similar. It's not clear to me whether this is actually required or whether you could just have an awaitable thing, but this is effectively what we've got. So something that's awaitable has to have a getAwaiter method, which we then, the compiler will call getAwaiter to get an awaiter, and then it will waiting, I will just call getResult immediately. Otherwise, I will make sure I've got a continuation, all onCompleted, and then return. And the onCompleted passes in a continuation where the first thing it does after getting the state machine to the right on the code is to call getResult. So you've got sort of the shortcut and the long path where it needs to actually await. And the idea is, however you got there, by the time you hit getResult, you should be back where you started. The two paths should be equivalent. Okay? Now I said this is a pattern. There is no such interface as IOwaitable or IOwaiter. There is an INotify completion that has this void on completed, and there's also a IE critical notification, completion notification or something, which has a void unsafe completed. Yeah.
Your pretend classes interface, it's very similar to reactive extensions.
Yes, I'm not at all surprised. The comment was this is quite similar to reactive extensions, which is sort of like a push version of IEnumerable, where instead of saying gimme, 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 you say tell me when you've got a result, tell me when you've finished getting a result, or tell me if there's a problem. So it's sort of an inside-out version of asynchronous, of immutable, and can often be used for asynchrony. And it has, I haven't looked at how the Reactor extension teams have integrated with async, but they have. So there are ways that you can, I think, adapt from one form to the other, and the way it's previously Reactor extension. So the compiler makes sure that whatever you try to await has a getAwaiter method, or an extension method called getAwaiter, which returns something which implements this pattern. An extension method, for those non-C# folks, is a method in a static class miles away from the actual type, which is decorated to say, I'm an extension method, pretend I'm an instance method on this type over here. So string doesn't have a reverse method, but you can define an extension method called reverse, and then call in quotes foo.reverse, and the compiler just says, right, I'll switch that round to be reverse, and then pass foo as the argument. So it's fine to do that as getAwaiter as well, to create a getAwaiter extension method on some other type. And that's in fact how the original technology previews of all of this stuff worked. They gave you some libraries, and the libraries contained extension methods on task of T, and task of T itself didn't have a getAwaiter. It does now, and they're able to make it more efficient. Okay, so we have, is it until 7:15, or until kind of 7?
We're not going to do our half time. Just do that.
Right, okay. So I've got about quarter of an hour. Let's show you something fun. We wanted to parallelize things. So let's run this demo. If I type in the real username password, put it on the debug, you'll see it's authenticating, sorry, it's so small, steps and holding, then about at 1.5, 2 second intervals, it's fetching into prices. I have another version of the code that has this in parallel. So if I do fetch prices parallel async, this looks fairly similar. So this takes the holdings and then transforms the list of holdings. I'm not going to get this on the line. Transform each holding into an anonymous type where the result is the holding and the result. And this is an asynchronous demo. So just like you can apply async to actual methods, you can apply async to anonymous methods. Effectively, this is building a list of tasks, and each of those tasks, when you await it, will give you the holding and the price. But it will do so asynchronously by calling into the price service and only returning the result when it's got the price back. And we call to this so that it's all not lazy. So by the time we've got here, we have actually started all the tasks to fetch all prices. And now all we need to do is iterate over the tasks and await them one at a time. And if we look now, we will see in debug, so it's still taking a while to fetch all the holdings, and then we get all the prices really quickly together. Looks better? Yes? Can anyone think of any slight problems with this? Yeah?
If the first task took 20 seconds and all the rest of them takes 2 seconds, then it's already 20 seconds.
Spot on, it's as if I planted you. Let's do exactly that. That really was exactly the answer I wanted. So our simple stock price service, right, so we'll say if these are the implementations of all of these things, all I do is await task.delay. So if ticker equals Acme, which I'm pretty sure is the first one that I've got, our data context. So John has Acme. Yeah, my real password isn't C#5 anywhere, so don't think you oh wait, passport delay 5,000. Okay, so this will be 5 seconds. So now when we run this, we would expect to see Absolutely nothing for quite a long time, and after about 5 seconds plus the fetching the holdings and fetching the price, we'll get all the stocks all at once in app, starting working. Okay? It's still okay. You're still getting the total as quickly as you can possibly get the total, but it's not ideal. We'd really like to see the results as they came back. Yeah.
So, what's the difference between asynchronous and multiple threading now?
Well, for one thing, this only uses one thread. So the benefits of that are it's not taking any more resources. Probably not a problem for a client app where you can afford the extra 1 mega stack. That's not going to kill you. On a server, if you have 1 extra thread per request, if there are long-running requests, that's going to be a pain. It also means that all of this code, you didn't see a single control dot begin invoke or anything else to get back to the UI thread, either to ask for data from UI elements or to add the portfolio thing. So it makes all of that easier because all of the code that I've written just runs on one code. A lot of this is making stuff that you could do before infinitely simple. Okay, everyone happy with where we are at the moment? I should write some magic. So, if I do tasks.in completion order and run it again, it does it exactly as the method describes. I'm going to iterate over those tasks in the order in which they complete. So we've got 4 of the results, and soon Acme will show up with the last one. Doesn't that sound like magic? I'm calling in completion order, and obviously they haven't yet completed. Let me show you how the magic works. So we've got a method called magic ordering. So we've got task extensions, and I have created an extension method for any sequence of tasks that you want to give me. I will give you them back in the order in which they will complete in the future. Not right. What I'll do instead is I'll give you the same number of tasks with the same results in the order in which they complete. So you give me 5 boxes that will eventually have cats in. I'll give you back 5 boxes that will eventually have cats in. They're not the same boxes. What I'm doing behind the scenes is I will create 5 empty boxes with holes in the back, which is the longer version of task completion source. So imagine this in terms of cats, okay? You've given me 5 boxes, I create 5 of my special boxes with a hole in the back. I then start watching each of the 5 boxes you gave me, and I also return these 5 boxes, and I know the order in which I've returned my boxes to you. I'll watch all of these. As soon as one of them, maybe it's the last one, comes back with a cat in, I will put that cat into the first box that I gave you back. When the second one comes, I'll put it into the second box. And so it continues. I think that is just delightful. So this was, I wrote a blog post a while ago demonstrating a different form of composition where I say, you give me any number of tasks that will return a value, and I'll let you know the majority verdict. So if you've got 5 different stock price services, then so long as 3 or more of them come back with the same result, as soon as 3 of them come back, I'll give you that result. If they come back with 5 different results, I can't give you a majority result, I'll throw an exception, etc. In fact, if I get 3 different results, then they can't, 4 different results, then they can't possibly be a majority verdict, and I can throw an exception before the final one has even come back, etc. And I implemented it in a very inefficient way, and someone said, well, why don't you just do this? And then you can just watch them as they come back. So that's the magic. Note that this isn't an async method, it just happens to return a sequence of tasks. I will very briefly talk about how you can unit test this.
Oh, yeah, do that. Give you perhaps
Right?
Let's see what you have to
Yeah.
Okay.
Absolutely. It's just an asynchronous task.
Right.
Yeah.
And let's assume that these 2 folks more than.
Right. Yep.
So I don't care about the rest.
Yes.
Can you do that?
Yes. So, what I could do is, what do you want me to do if so you want to get
At least 3 quotes that come back within.
right. I'm not going to code it now, but what you could do is have 2 tasks, one of which would process things as they came back, and one of which would be a delay for 3 seconds. And they would both have a cancellation token that you pass in. This is normal stuff from .NET Core to say, I can cancel you whenever I like. It's up to you to watch and do the appropriate thing. And I can say, which is going to complete first, the delay or the processing all the things. And whichever completes first, I'll cancel the token, and either the delay can stop if we come back quickly, or you can stop processing.
And what I want to do is do at least 3 of them, not necessarily all 5.
Right, at least 3 with a maximum time.
But I don't wait more than X amount of time.
Right. So what happens if we've only processed 2 and you've got 3 seconds?
Absolutely fine.
Right.
Let's say
So-
at least 3.
So
At least 3, but not greater than this amount.
right. All of this is doable, but I certainly wouldn't write one routine to do all of those. Instead, I would write various building blocks, and the great thing about all this being composable in the same sort of example that you've given is you can write each bit, and so if you wanted something that says, give me the first n results out of them, that's really easy to do, and cancel the rest. And I can do another thing that says, and take at most this amount of time. And I could probably do something else that says, give me, I think we would have to work out the policy side carefully, and then work out how to decompose it. And then you always put those blocks into it. Yeah. And one thing I haven't explained is how exceptions work in all of this. And basically, you can either make sure that it looks more. There's a slight hiccup in that multiple things can go wrong in some cases, certainly when you do a task dot when order, which says, I've got loads of tasks, let me know when they've all finished. If all of them go bang, then you've got 5 exceptions, or however many exceptions. And the way that the normal try-catch works with async is it says, if there's at least 1 exception in the task, so task dot exception returns an aggregate exception that can contain more than 1. The compiler says, I'll just throw away, or the awaiter says, I'll throw away all of the first. And you can catch the first in a strongly typed way. And that's almost always what you want. But you need to be aware of when there might be multiple exceptions, and then you can always ask each of the original individual tasks what their exceptions were. Or I've got another extension method on task, I don't think I've got it in here in fact, that says, actually don't unwrap the exceptions, give me back the original aggregate exception. So you could do try to task dot with multiple exceptions, just as an extension method. That returns something that implements the awaitable pattern. And then catch aggregate exception, I'll look at all the exceptions. So it's really easy to add that when you want to, and most of the time, frankly, you're not going to manage to think about multiple things going on at the same time, or you don't care. Right, we're pretty much out of time. I'm not going to even start with the time machine. So in order to unit test this, really you want to be able to, to say, well, what happens if 2 of them complete and if we've got 3 tasks and they complete in order 2, 1, 3? Well, I want the return tasks to complete in the right order, and the first one already have completed when task 2 has completed because it's the first one, etc. I will show you that it is possible to unit test it. So, as an example, I create a time machine, I schedule success cases, so these tasks will actually complete in order 1, 2, 3, but then I'm going to create an array of them out of order, 2, 3, 1, And then I can say execute in context, which is pretend I'm in a single threaded context because I really, really don't want threads involved in my tests. That's the root to taking this. I've got an enhancer, which is like a sonic screwdriver of time, so I can say I'm going to call my production method in completion order. I'm going to advance time to t equals 3, and then all of them should have results. And that's one task, one test, and the results should be in the order that we decided they were completing, not the order we provided them. And then there's a slightly longer test that says, before we start, at t equals 0, all of the tasks returned by method should be waiting for activation. Then when we've advanced to t equals 1, the first one that we gave back should have said, hey, I finished, and the other two are still waiting. And when we advance time again, the final one. I'm not going to go into the actual code involved in that, but just take away the idea that, hey, you can, after we've advanced time again, the next one we're using things that are testable, of course. So here we're passing in tasks directly. And we would find, if we were unit testing some production code that used our authentication service and our portfolio service, we could say, use normal blocking frameworks to say, when you're called to ask to authenticate user John password 2, then return this task that comes back from the time machine and will finish in a certain way at a certain time. Okay, right, that's the setup done. Now for my method, okay, advanced time, oh yes, the result was it failed authentication and we didn't call into the whole. So it's testable, it looks like magic, feels like magic to work with it, but as you can see, there's good stuff underlying it. I didn't show you the horribleness that is the decompiled sample code. So, as an example of this little async method, it's got a loop, it's got a couple of awaits, but it's less than a screen full of code. The code that's generating for that is all of this. Lots of go-tos, lots of all kinds of stuff. I've subtitled other talks around async go-to considered awesome. So long as you're not writing or reading the go-to, it's fine. The compiler does a great job. So all of this is just about predictable if you want to go into it all. It's not magic, it just feels like it when you want. And that's basically it. So I hope if you're using C# that this will encourage you to dig in deeper. There's so much more to know about it, but it's really, really great. Thank you.
Now there are going to be some questions at the end of that. And if you want to ask a question, that'd be nice. So where's the spaghetti?
The spaghetti is all in what the code would have looked like if we weren't using async. So if we tried to do this with continuations manually, it would have been horrible. We'd either have had each bit, well, I can't even think about how we would have done the loop bit of looping over all the prices, because when each one finished, we need to remember that we still had some to go. So we probably need to extract an extra class to hold that state information. And yeah, it gets yucky. I would almost certainly have forgotten that when we've authenticated, if we got the username and password wrong, we still need to re-enable the fetch stocks button. That kind of thing. You know, we've got 2 exit points from our asynchronous method. So I finally makes it really easy to re-enable stuff. With continuations, hideous mess.
Another way of looking at it is you have to write up your own code.
Yes, yeah. Obviously you wouldn't write anything quite like this, but it would be pretty hideous nonetheless. Who is that?
You had to write
Can you just wait for the mic?
yeah, sure.
Try to record this.
Posterity. Hello, posterity.
You had to write your incompletion order.
Yes.
That should be part of the standard library in C#.
It's a Yeah, so the question is, should combinators like incompletion order be effectively part of .NET? I think it would be interesting to have them as part of .NET. I suspect the problem is that no one, not even Microsoft, has enough experience of how people are going to actually productively use this yet to know what building blocks to provide. And if you provide the wrong building blocks early on, that's death. However, there's something called TAP, which is a task asynchronous pattern. So a white paper from Microsoft that you definitely want to read, written by far cleverer people, which contains all kinds of combinators at the end of it, including incompletion order. They call it interleave. Incompletion order is more, it says what it does. But there's all kinds of things here. There's return when the first has finished, all kinds of bits and pieces. So I'm sure that people will be rolling their own, probably wrongly, for a while, and hopefully in a future version, either a future version of .NET, or I suspect actually Microsoft will eventually publish an extra package on Lua that is, here's a load of goodness. And there is also one package called Dataflow, which is a set of things that plays nicely with the task asynchronous pattern, and is particularly geared towards producer-consumer type environments.
I mean, in your simple example, you needed that straight away, so it's pretty obvious it's needed, really, isn't it?
Yeah, well, it's needed there. There are other ways of doing things. We could have just attached continuation directly.
But yeah, it's a straightforward way of getting an optimal result of seeing moving through. So
yes. What I didn't say is, hey, if the first one to return throws an exception, we won't notice what the other ones are doing. So maybe you want to pass in an exception handler that is attached to everything that hasn't already passed, or something like that. It's that sort of detail that comes with experience. My guess is that Microsoft will be watching quite closely what happens with this stuff. I really hope this is widely used. In Windows 8, you haven't got much choice other than to use this because everything's asynchronous. So you either do it by hand or you don't do it at all. Whereas in the previous world, people would just say, asynchronous is too hard, I won't bother trying. I'll either do things in the UI thread or I'll shove it all over to a different thread and fall back when I need to.
Sorry, carry on. Is there anything within the extensions or with the Alex language to deal with thread and see it's sort of like a inference in some ways?
So it hasn't been added to the platform in that it's been there since .NET 2, synchronization context. And it depends on the awaiter. It's up to the awaiter to work out, hey, I will pick up the synchronization context. And in fact, you can call an extension method on task. I can do await task dot configure await and say continue on capture context false. In which case it will say, well, I actually don't care about continuing on the same thread. So all of this was previously available. There is the idea of any thread is in a synchronization context, or it's not, which is sort of equivalent to the critical one. So all of that is already sort of done.
Yeah. Just making another question. You have the example where you want to get a majority price.
Yep.
And just a more complicated example. I was thinking about a simpler one, but I'm wondering is it actually implemented to any simpler? I mean, suppose you want to start a both, right? So you're having a number of tasks and they're all going to come true or false.
Yeah.
And you just want to get the majority, which clearly once you've got what's either true or false is more than half.
That's exactly the same.
Yeah, but do you still have to construct the new list of the new array of list of tasks, or can you always do it without even doing that?
Well, you've got all the tasks,
The original ones, but you had to construct new ones that you returned, didn't you?
Oh, the incompletion order
Yes.
happens to, because that's returning a set of
Can
tasks.
you do it without that incompletion?
If you're doing yeah, I didn't show the majority voted one, and that wouldn't return a sequence of tasks, it would just return a task of two. So it's got to return one task. In theory, no, it does have to create one new task to be a placeholder for when I've got the majority, that will contain that majority.
Not all the
Majority.
Right. Okay.
any more questions?
You can chat to me later on, but
Absolutely.
or email me.
Absolutely. I have a yeah, some people put it on their slides.
If you just search me on there, you'll find it. And will you give us the URL to
I can do so. Let's just see. I don't remember that, but yeah, it's the task case should be easier to find.
We've known for a couple of decades that writing training programs is very difficult. And this is fantastic. So I want to thank John for running this video for really good. Please join me.
Very easy to talk about language.
Right, okay, now, John, 2 seconds break. I'm just going to come out of my.
I've got some slides on this machine, so can I borrow it?
Do you want me to finish?
Yeah, yeah, that's great. Just do exit.
Uh,